In today's lesson, we're going to be talking about slopes of parallel and perpendicular lines. So we've got just a couple learning targets here. We're going to be able to describe the relationship among the slopes of parallel and perpendicular lines, and then you'll be able to write an equation of a line that contains a given point and is either parallel or perpendicular to a given line. So we need to do some investigation here first to make sure we kind of fully grasp the relationship and what's going on. So we're going to investigate the graphs and equations of a couple different lines here. So first thing we're going to do is write the equation of the line that we have graphed here. So this is something that we've done in the previous lessons. And there's a bunch of ways we could go about this. We could write our answer in point slope form if we wanted, because I have 3 different points listed here. Now, because one of those points happens to be on my y-axis, that means that this is my y-intercept. So I can see that my y-intercept is at the point 0, 4. Which tells me that when I'm looking at y equals mx plus b, that b is 4 here. And I can also use these dots to count rise and run in order to get the slope. So I'm going to count my rise and my run. So from this y-intercept point to the next point, I did a rise of 1, it went up, so that's positive. And then once I went up 1, I went to the right 1, 2, 3 units. So run is also positive. And so that means that my slope is 1/3. Remember to use your common sense kind of visual check that this is a positive number that I wrote down for the slope, and this number or this line does rise to the right. So that checks out. So when I go to write the equation, I do y equals, if we're using slope-intercept form, that'd be mx, so my m is 1/3, so 1/3 x plus b, my b is 4, so plus 4. So this is the equation of my line that I have graphed there. So the next thing I want to do is graph this line, y equals 1/3 x minus 7, on that same coordinate plane. So in order to do this, this is in slope-intercept form as well. So again, this is using y equals mx plus b. So we need to identify what is my m in this equation and what is my b in this equation. So mx, so in front of the x should be my m value, which is 1/3. Remember that 0b is my y-intercept. So that's the first question I want you to think about and answer is what, as an ordered pair, is your y-intercept for this line right here? Okay, so the number that is b in this equation is -7. Again, when you look back at your notes, when we first did slope-intercept form in 12.1, the 12.1, 12.2 notes, it's always 0, b. So 0, -7 is what you should have for your y-intercept. Now, again, you might be saying, why is she writing this down? It just says to graph it. Because this is the key information that I need to graph. And when you go to do this on a test or on your air test or any of those things, you need to make sure that you've written things down that are going to help you. And for me, I'll give you partial credit for stuff like this because that tells me you know something even if you ended up graphing it wrong. So I always start my graph at my y-intercept, so 0, -7, so 2, 4, 6. So here's 0, -7. And then since my slope is 1/3, that means rise 1, run 3, rise 1, run 3. I'm just continuing the pattern as far as I can. And then remember, this could also, because 1 over 3 is also the same as negative 1 over negative 3, so I could also rise negative 1, run negative 3 to get the points on the other side. And so then that takes us all the way across. All right, so C, what is the relationship between these two lines? So when you look at these two lines, what would we call this? They're two lines that do not intersect, and it looks like that if they kept going on forever, that they still wouldn't intersect. So hopefully you know that those lines are called parallel. So the relationship between those lines is that they are parallel. What do you notice about the slopes of these two lines? So my m's, if I look at the m here compared to the m up here, we should say that the slopes are the same. And this is one of the things that you just need to know, is that parallel lines have the same slope. This isn't just some coincidence for these particular lines. This is true of all parallel lines. If the lines are parallel, they are going to have the same slope. All right, so next thing we're going to do is graph this line in the coordinate plane. So this line is not in slope-intercept form. This is in point-slope form. So we're kind of reviewing our forms as we go, which is helpful. So remember that point-slope, y minus y1 equals m times x minus x1. And so my m is the number in front here. So m is negative 3. In this case, and my point, remember it's always the opposite sign. So since this is a minus in the equation, it's a positive value in the ordered pair. Since this is a minus y in the equation, it's a positive in the ordered pair. So this is telling us that my new line, I should start at the point 3, 5, and then I should use a slope of negative 3 when I go to graph it. So I'll go to the point 3, so right 3, up 5, so that's convenient. We've already got a point there. But from here, we are now going to do a slope of negative 3. So that means that my rise over run has to equal negative 3 in this case. So that could mean that it's negative 3 over positive 1, or it might be negative 6 over positive 2, any of those values. So negative 6 over positive 2, or maybe it's positive 3 over negative 1. So all of those would work. So I'm going to go down 6, right 2. So 1, 2, 3, 4, 5, 6, right 2 to get myself another dot. And then down 6 again, 1, 2, 3, 4, 5, 6, right 2. I think I missed. Hold on, let me count again, because this was at 5, so 6 should be at negative 1, and so then another 6 should be going to 7. Okay, so I did miscount a little. So here's down 6, here's right 2. And then I don't have room to go up 6, left 2, but I could go up 3, left 1. So up 1, 2, 3, left 1 would still be on the same line. So I'm going to try to connect this as best as I can. All right, so when we look, part E, we've graphed it, which was the end of part D. Now part E, what is the relationship between the original line, so the one that was in blue, and the line from part D, which is in purple? So what we should notice here is that it looks like they're making a corner. And you learned way from elementary school and again in middle school and probably again in junior high that when those lines make a right angle or make a corner, that those are called perpendicular. So the original line and this line are perpendicular. What do you notice about their slopes? Now this one I'm probably going to have to help you with because the two slopes that we're looking at were -3 and +1/3. So what we call those is it's actually two things. First of all, they're opposites, meaning one's positive and one's negative. But they are also the reciprocals of one another because 1/3, when I flip it, would be 3/1. So the slopes are opposite reciprocals. So, for instance, if I had, let's say, a slope of -2/3, the opposite reciprocal means I need to do two things. I need to flip it, so 3 goes on the top, 2 goes on the bottom, and I need to change the sign. This was negative, so this was positive. So these two values would be opposite reciprocals of one another. If I had a slope of, say, +5, the opposite reciprocal of that, 5 is really 5/1, so when I flip it, it becomes 1/5. This is positive, so I would make my opposite reciprocal negative. So I hope that illustrates for you. I want you to try one now. So if I give you the slope, let's say 5/6. So if my original slope is 5/6, I want you to decide what the opposite reciprocal of that 5/6 would be equal to. All right, so again, two things with perpendicular lines. First, we have to flip it for the reciprocal part, so 6/5. Then we need to make sure it has the opposite sign. This original was positive, so my opposite reciprocal would need to be negative. So hopefully you picked -6/5. If you didn't, I hope that this makes sense why that should be the answer. So the two new statements that you have to memorize are that parallel lines have the same slope and perpendicular lines have opposite reciprocal slopes. All right. Example 2, write the equation for each line graphed. So when I look at these lines, this is a vertical line. When I go to write an equation of a vertical line, first of all, it doesn't have a slope because the slope is undefined. Secondly, it doesn't have a y-intercept because it never crosses the y-axis. In fact, it's parallel to the y-axis. So it's important that we know how to write the equations of these special lines. So all vertical lines, no exceptions, they are always just x equals a number. And the number that it equals is whatever x is equal to everywhere on that line. I could pick tons of points on this line. They all have the same x coordinate. And so the x coordinate there is 8. So that means that my equation here would be x equals 8. Now, if you couldn't remember that, you could pick 2 points on the line, figure out the slope, which you realize is undefined, and then use point slope form. You could eventually get to that x equals 8, but it's much, much easier if you just know it. In B, this is a horizontal line, and horizontal lines, it's the same idea. The slope is 0, and we do have a y-intercept, so this one is easier than the vertical line if you forget the rule. The rule for horizontal lines is that they're always just y equals a number, so there's no x in the equation of a horizontal line, just like there's no y in the equation of a vertical line. So this is for horizontal lines. And so we look, and the number that y is equal to here is -3. If you forget that, again, you could say, okay, well, I know in y equals mx plus b, my m here is 0, 0x plus -3, and then 0x is just 0, plus -3 is minus, and you would end up with the exact same thing. But again, much easier to just know the rule as is that for horizontal lines, we just write y equals a number. All right, so what relationship do these lines have? So meaning, if I graph this line, y equals -3, so that would go right here on the same coordinate plane as my original, we should be able to tell what kind of relationship those have. So go ahead, that's the next thing I want you to answer, is what relationship do these two lines have to each other? All right, so hopefully you decided that those were perpendicular, which leads us to these statements that are really important. Vertical lines are blank to vertical lines. So think about it. Should that be parallel or perpendicular? So if I have this vertical line and I draw another vertical line, hopefully you can see that those ones would be parallel. Vertical lines are blank to horizontal lines. Well, this vertical line, this horizontal line, they are perpendicular, always. Likewise, horizontal lines are parallel to other horizontal lines, and they are perpendicular to vertical lines. So now that we understand the relationship, we need to be able to use that information to actually write equations of lines. So when we look at example 3, we're going to have a couple different ideas here in A through D. In A, it says write the point slope form equation of the line that passes through the point 8, 1 and is parallel to the line 3x plus 4y equals 4. So whenever you have a question like this, we need to take the equation of the line that we're given, and we need to use the given line for its slope. So this equation happens to be given to me in standard form, which means that if I want its slope, the slope of a standard form line is always going to be the opposite of A divided by B, or you can just solve for y, which is what most people do. So if I solve for y in this equation, so 3x plus 4y equals 4, so minus 3x on both sides, and we've got 4y equals negative 3x plus 4, and then we divide by 4. We don't care about simplifying the rest. All we care about is the number in front of the x. So the slope of my given line is -3/4. So I use this to determine, okay, my line is parallel to this line. And I know from this statement that I'm supposed to have memorized that parallel lines have the same slope. So if this line has a slope of -3/4 and my line's parallel to it, that means that my line also has to have a slope of -3/4. Now, I know my slope, and I'm also given a point. This is my x1, y1 in point slope form. So now I just need to plug these in. So go ahead and I'll do y minus y1 equals m, which is -3/4, times x minus x1. And it does say in the directions that my answer should be in point slope form, so I don't need to do anything else here. All right. Part B, write the slope-intercept form equation of the line passing through the point 6, 8 and perpendicular to the line y equals -1/2x plus 4. So again, use the given line for its slope. The slope of this line is -1/2. My line is perpendicular to this line. So, according to what I know about perpendicular lines, the next thing I need you to do is to determine what my slope should be for my line. So the slope of the line it's perpendicular to is -1/2. You decide what is the slope of your line that we need to write the equation for. All right, so again, my line is supposed to be perpendicular, and I know that perpendicular lines have opposite reciprocal slopes. So the reciprocal of 1/2 is 2/1, which is just 2. And then I need them to be opposite. This is negative, so this should be positive. So m should equal 2. Now, I know that my line needs to go through the point 6, 8. This is not the y-intercept. So I can't go directly to the form that I'm asked for, the slope-intercept form. I need to use point slope form first and then convert it over. So y minus y1 equals m times x minus x1. And so now, as we talked about in our previous lesson in 12.1, 12.2, in order to get from point slope to slope intercept, first I distribute. So that gives me y minus 8 equals 2x minus 12. And then I need to add. So these go away. And I have y equals 2x minus 4. So y equals 2x minus 4 is the equation of my line that goes through 6, 8 and has the slope that's perpendicular to this line. All right, nearing the end, home stretch here. Write the equation of the line that passes through 2, -3 and is parallel to the line graphed at the right. So this line. So since this line is vertical, that means my line must be vertical. Because vertical lines are parallel to each other. I also know from what we talked about earlier that vertical lines take the form x equals the number. So I don't need to do a bunch of complicated stuff here. I just need to look at the point that was given and find what the x is. X equals a number. In this case, that number is the x coordinate. So x equals 2 would be the equation of my line. If you aren't convinced, then go ahead and graph it. If I plot the point 2, -3, so right 2, down 1, 2, 3, and draw a vertical line through there, that would be x equals 2. So I know that that's correct. All right, last one. Now we're going to write the equation of the line that passes through that same point, so this point here, but is perpendicular to the line graphed. So the line graphed is vertical. That means my line must be horizontal, because as we wrote in the above section, if I want a line that's perpendicular to a vertical lines are perpendicular to horizontal lines. And look at the way we write horizontal lines. Y equals a number. So what you need to do next, and last thing to do, is to figure out y equals what. What equation should we be writing for this last one? It goes through this point, 2, -3, and it needs to be a horizontal line. All right, so going through this line, if you look at it, if you eyeball it, or even if you actually want to graph it here, the y value at all of those points on that line is -3, because that's the y coordinate. So y equals -3 should be your answer there. All right, so again, you must have these guys memorized. So if you're making flashcards, I would suggest that you maybe write parallel lines have blank slope on one side and write the same on the other, and then do the same idea with the perpendicular lines and the opposite reciprocal slopes. So we've given you examples of all kinds of everything, so make sure you reach out with questions that you have.